Hello everyone, my name's Dr. Phil Winder and I'm the CEO of Winder AI. Just a quick background about us before we get started. We are an AI agency. We help companies with their AI consulting and AI development needs. We've been operating since 2013, and so we've done many tens of projects, probably coming up to nearly 100 now. I haven't actually counted, I probably should. We've worked for some of the largest companies in the world and also some of the smallest, but all of our work has been around AI or machine learning or data science or whatever you want to call it. In today's talk, I want to talk a bit more about AI strategy with a focus on leaders. And what I want to try and do is give you a little bit of a playbook around some of the most important decisions that you need to make when you are considering investing in or running an AI project. So hopefully you'll find this useful. If you've got any questions, then since this is a recording, I think probably the best way of asking me a question is over email. My email is phil@winder.ai. I'll leave some links at the end of this presentation to remind you. But basically, if you go to winder.ai, then you should be able to find me, or just search for me. I'm all over the internet as well. So, all right, let's get going. So the first thing that I want to talk about is the increased use of AI. Basically, this is just a plot that I've pulled from some data according to McKinsey. So, pinch of salt in terms of the actual numbers. They tend to survey like larger enterprises rather than smaller ones. So it's not a true representation, but it's a good indication of what is happening in the market. So AI in general has been used quite, in a significant way since 2017. I would say that was really when we first started working on core ML and MLOps projects. Before then, it was more data science projects, like pure understanding your data and trying to extract value from the data itself to help with decision making and analytics and things like that. That's kind of what we were doing between 2013 and 2017. 2017, we started seeing a rise in like pure machine learning automation projects. So we were developing models to achieve, decision making tasks in enterprises. Fast forward a bit, then you'll see that there was a kind of saturation 2019, 2020. I'm not entirely sure of the reason for this. I think maybe we got to a point where the enterprise kind of thought that they had reached maturity, even though we hadn't entirely seen that. It wasn't until after 21 or 22 when OpenAI came out with their GPT models that it really reinvigorated AI again. And it did that by expanding the market, really, expanding what was possible compared to before. So prior to 2020, we were working with very sophisticated, complicated, purely numeric models. And after GPT-style, transformer-style models were announced, people started to work with them in raw text. And it was really that spark, that process that what I'm trying to say. It was really that which ignited a reinvigoration of trying to apply AI in the business. So we've got a new line in orange here that started around 2023 when they started to collect this kind of data of GenAI being used in business. So specifically, not just machine learning, not just reinforcement learning, specifically using generative technologies in business. And you can see that has peaked incredibly quickly and caught up to the rest of AI. So I think the thing to take away from this is that actually it's not a particularly new set of technologies. It's quite mature now. People have been using them for a long time. And so yeah, if you're interested in starting some of these projects, then you should get going. I normally then like to present some kind of horror slide where you're saying most projects fail, something like that. And you can always find those statistics. But actually, I thought I'd flip it on its head and start presenting some metrics to show you how successful some projects can be. We've got a couple of different metrics here. The first one from McKinsey again is attributing 17% of companies agreed that more than 5% of their EBIT, their profit basically, is coming from GenAI, like is can be attributed to the use of GenAI. So I think that is a really, really positive figure. That's saying that, approximately 1/5 of enterprises are now saying that it is contributing to significant revenue. And you can postulate as to why those 4/5 are not getting that kind of return on investment. And hopefully after this presentation, you might realize some of the reasons why they might not be achieving that. But I think that highlights that it's definitely possible, and it is significant. 80% of enterprises have 50 GenAI ideas in the pipeline. I find this one a little bit hard to believe. This is from a company called ModelOp, and that is a really high figure. I think that, it depends what you mean by ideas and in the pipeline, but yeah, I would suggest that maybe 4 out of 5 maybe have high hopes, but as we've seen, only 1 out of 5 are actually doing anything significant with them. So there's something wrong with one of these statistics. And when you start looking at smaller companies, especially startups, then a report by MIT found that over a quarter, or I think it was exactly a quarter, which is a little bit worrying. I hope they rounded that number down or up or something, but something very close to a quarter were generating, reasonable small business revenues within 12 months. So irrespective of whether you are a big business looking to improve revenues in an established business, or if you're a new startup attempting to break into a market, there's avenues for both. So I think what I want to focus on today is to try and highlight what those successful companies look like. Hopefully it'll give you a few patterns and ideas of how to apply this to your business. The 3 I've picked, or the 3 I'm focusing on anyway, is picking the right use case, focusing on attempting to deploy into production, and partnering with experts. So the first one, picking the right use case, this has always been the case ever since we started in 2013. If you don't pick the right problem to solve, then the eventual solution, it might be technically excellent, but if it doesn't meet the needs of the business, then it can always fail. So you need to focus on picking the right use case. You need to pick the ones that will generate the highest return on investment. You need to pick the simple ones, the quick wins. It's all normal engineering practice. And a survey by Deloitte found that 74% of enterprises say that GenAI initiatives meets their ROI expectations. So I think it is reasonable to expect that you should be able to reach a return on investment that makes sense for you. Another thing that successful teams do, and I think this is a bit of a hangover from like DevOps, really, I guess, is that the faster that you can push production AI deployments, the faster you can move your AI deployments into production, the more the work you can do, basically. It's as simple as that. I mean, it makes sense when you kind of break it down. Like if you deploy more, some of them will be successful. I think this is a fairly well understood idea. Most successful companies are able to take something from ideation to production in less than 6 months. Kind of depends a little bit on the complexity of the project. Sometimes if we're working on a massive, we've worked on a couple of massive projects for a couple of, mega enterprises, and they've taken up to a year sometimes because the problem was so complicated and required so much work to get working. But in the vast majority of cases, 3 to 6 months is kind of that sweet spot of going from not really knowing anything to something in production. So that's kind of what you should be aiming for. And partnering with experts, that same MIT report that I mentioned earlier stated that projects meet expectations 67% of the time when they partner with an expert. If they do not, then it fails quite often. I can't remember the actual number. It was only met expectations maybe 15% of the time or something. Basically, this is evidence to point towards the fact that you need experience in this to be able to do it effectively. So it helps to partner with a company like Winder AI. All right, I've used the word AI far too much and I haven't defined what I mean by AI. Unfortunately, I still have to do this in every single presentation because every time I speak to someone, they have a different idea or concept of what AI is. So for the purposes of this talk, I'm kind of focusing on GenAI and LLMs in particular. This is a conference about LLMs in production. Therefore, I'm saying AI. I'm using the word AI in a technical sense, where I use the banner of AI to kind of encompass all of the underlying disciplines that feed into large language models. So I'm talking about machine learning. That's at the heart of it. We are training a predictive model based upon natural language data, so natural language processing. Reinforcement learning is used a lot to train these models as well. And these models tend to be really, really quite huge. They're very sophisticated and specialized architectures, model architectures. General term for that is deep learning. So all of these things feed together to build what is known as a large language model. Okay, when I say AI in general, I'm talking about machine learning, reinforcement learning, or even the application of pure data science to usually, automate some kind of process within the business. But as analytics has shown, even just the information itself can be really useful and valuable. Quick note, a shameless plug on the reinforcement learning piece. I am also the author of O'Reilly's reinforcement learning book. So if you want to learn all about reinforcement learning, check that out. Website is rl-book.com if you'd like to learn more. Okay, so in terms of high impact use cases, I said the use case, the problem definition is really the most important part of the whole process. If you get that right, then actually it can make things really easy. What we're trying to do here is we're trying to find a problem and a use case that is both easy to do and valuable. So one of the best things to start off with is to try and map out the value within your business and drive the AI projects towards that value. So the most sort of high impact use cases you can focus on can generally be decomposed into two main themes. The first one is to improve your product. So basically you're trying to improve the efficiency or the user experience or the workflow of your customers. So it's a pure product sort of perspective. The second version is operational efficiency. If you are trying to improve the way your business works, if you're a highly kind of process oriented business, then there's quite often high impact use cases on the operational side. Once you've figured out the theme that you're going to work on, then measuring the measuring the return on investment is hard. And therefore, estimating the return on investment is equally as hard, but it is achievable. And some people even specialize in attempting to measure and predict their ROIs. In general, it's all about trying to estimate how much time is currently being spent doing something and what that time is worth, and then equating that to some monetary value. Lots of inspiration already out there. On the internet, so yeah, definitely check them out. There's one I saw from Google that tends to focus a bit more on large language models, and they've come up with a massive list of real world GenAI use cases. However, not quite. However, I've got another slide in between the however. Sorry, I'll come back to that in just a moment, because it's really interesting finding that a lot of items in their list are actually not LLMs at all. So when you start thinking about once you've figured out what problem that you want to solve, then you need to start thinking about how you're going to solve it. And I think it was 1999, I reread Pragmatic Programmer the other day, and even though that was released, I think the copyright said 99. even though it was released 25 years ago, it still makes sense today. It still talks about the art of attempting to build a system in the most efficient way possible. And you do that by not biting off too big chunks. You're trying to solve the simple problems first, and you work your way up to it. Basically, don't over-optimize before you need to. And that applies in the AI world as well. You don't have to go from zero to full AI automation. You can take steps. And I think there's at least 4 different distinct phases that you can go through. So if you think of this as like your AI maturity, you're kind of going through the different phases and becoming more AI literate as you go. Typically, when you go down this list, you will also meet fewer and fewer use cases. For you're kind of specializing more and more. You're getting more niche and more niche. So the simpler solutions and the simpler technologies tend to have a more wider applicability. So level 0, where I'm starting at, is simple LLM integration. So one of the easiest things that you can do as a business is to start integrating generative AI capabilities into workflows by, pulling in off-the-shelf APIs and things like that. Then we've got data-intensive workflows, multimodal and optimization, and agentic systems. So let's go through each of that in each one at a time. So if you are starting from the beginning and you are attempting to integrate LLMs into your workflows, then you need to identify these repetitive text-based tasks. That's the ideal use case for these AI models, for these LLM models. You can use an off-the-shelf API to interface with these existing models, and you can use very simple prompting and testing to ensure that they're doing what they're supposed to do. You've got to remember to always look at your return on investment, measure the time saved and quality, and try and verify that you've met your expectations. So examples of these types of use cases look like any kind of document processing. So if you've got a document-heavy process within your business, then it's highly likely that there are parts of that, or maybe the whole thing, that can be improved or replaced with LLMs. If you're an engineer, then code reviews is like a really simple, obvious use case. You can automate the code review process by using off-the-shelf models these days. Content generation as well. These are all of the use cases that they're kind of self-explanatory. They're obvious. You've probably heard of them. Probably don't need to say much about it. But these are 10 a penny. There's many use cases. They're everywhere. They're really easy to find. And they're usually quite easy to do. So I definitely recommend getting started with these immediately. All right, so let's get into something a bit more complicated now. The next level is when you have a data-intensive workflow. So many domains have, many businesses have a domain where the data is quite complicated and the data is very specific to their business. And this is really powerful. I'll come back to the value of this data later. But that data is really valuable because it's what basically defines you as unique compared to every other company in the world. When you have this domain-specific knowledge or data, and when you have a kind of consistent output that you need, then you can start integrating these off-the-shelf models with your proprietary data. And you do that with various kind of integration techniques like retrieval augmented generation, or maybe you're integrating LLMs with access to internal APIs. But you can still use standard off-the-shelf models. It's like an addition of off-the-shelf model plus your data. Again, you need to evaluate the performance and measure the ROI on that, but this works really well. We've got an example from our website if you'd like to take a look at the slides after this. We've got a use case where we helped a legal, let's just maybe summarize it really quickly. We've got a use case where we helped a legal team to research and analyze laws for a very specific question that they had in mind. And that was done by integrating their proprietary data with off-the-shelf LLMs. Customer support is another obvious use case here. Quite often the generative capability of a large language model isn't good enough to answer your customers' questions. You usually need some integration with other systems or other data, and this is a perfect way to do it. Second level, multi-model and optimization. This is where you get to a scale where you start realizing that actually you're spending a lot of money on these off-the-shelf LLMs. You've got maybe a very high volume, high scale task that is using a lot of tokens, it's using a lot of these models. And then you start thinking about, well, how can I A, start saving costs, and B, improve the model so it performs better for my specific use case. And you can do that by incorporating your data again, but you do it in a slightly different way now. Firstly, you can do it via routing. You can, based upon the question or the task, you can route that request to a better suited model for that task. You can start fine-tuning your models. That's basically training your own models off of base models to improve performance in your specific task, and start leveraging open source models. They are really, really great these days. We use them a lot. They perform really, really well on a wide variety of tasks, and their superpower is when you need to use a really small model for a very specific task and you have some data that represents that task. Works really, really well. Search is probably the most common use case here. That probably uses all of these things. It uses routing to route to a model depending on the search term, uses fine-tuning to improve the search process, and it probably uses open source models because you can't really buy an off-the-shelf search API that uses LLMs in the background and your data. And then we get to really kind of the state of the art and also the state of the hype loop. Agentic systems. This is when this is useful, but it is only useful in a very limited subset of all of these use cases. An agentic system is something that, like a reinforcement learning agent, so link back to my RL book there, like a reinforcement learning agent, an agentic system runs in a loop and it is attempting to achieve a task autonomously according to some kind of reward mechanism. And it has the ability to do that and sometimes even learn on the job as well, if it's an online learning system. That is very rare in the LLM space, but it can be done. So this works really well for situations where you have a workflow that is not repeatable and not linear. In that case, it's very powerful and very useful, but only for these really sophisticated use cases. Maybe won't go into too much detail there. I definitely recommend checking out reinforcement learning and how RL models this problem, because it'll give you a lot of intuition as to where agentic systems work really well. I mean, when you do actually implement them, though, they're typically quite simple to implement. They're basically a big while loop. They are connected to tools. You give the agent the ability to call these tools. The real difficulty and the challenge is writing that reward signal, writing that prompt to define what it should do and when is actually really, really hard, especially when you've got a nonlinear, complicated system to work within. The most common example you'll see of this is an agentic coding assistant. All coding assistants are agentic because the goal is to help the user. Still, it's a fairly simple reward, but they have access to lots of tools to be able to do that. So they need to run in a loop in order to achieve that. And if you've ever used an agentic coding assistant before, you've probably had situations where it gets stuck in that loop, or maybe it goes off on a path that you never intended and you have to reset it. And it's purely because it's really hard to define these reward signals in these complicated systems. So there exists a 80-20 type rule for AI. And you'll find that the vast majority of problems within a business can actually be solved really quite simply. Off-the-shelf models, potentially simple machine learning projects, RAG integrations, potentially prompt engineering. It's that last 20% that requires significant effort, significant time, and energy to get right. So you need to, if you do find yourself within that 20%, you've got to be really sure that the ROI makes sense. So let me go back to that Google list of 601 LLM examples for a moment, because I just randomly picked out a few of them, and I sort of went through them, and I'm just going to sort of take you through the path that my mind went through when I read these. So the first one, Spotify handled massive scale through BigQuery with personalized experiences, 675 million people. That example has nothing to do with LLMs. It's not even machine learning. It was just talking about how they're using BigQuery to scale some big data type process. Next one, Trumbull Insurance Agency is using Gemini and Google Workspace to significantly improve its creativity. What they mean by that is that they're using Gemini to write some emails. So again, that's completely off the shelf, not really doing anything novel there, barely even a use case. Mercado Libre has incorporated semantic search into its digital shopping platforms using AI embeddings. Okay, so this is a bit more of a sophisticated example. This is using embedding models, which are models that convert text into a numeric representation of that text, and then they're using it in their search functionality to find similar products. So that's a pretty sophisticated use case, but it is just an embedding RAG-like use case. It's nothing. It's still using off-the-shelf models. It's unlikely that they have trained their own, so it's still fairly simple. Grupo Boticario employs real-time security models to prevent fraud and detect and respond to issues. Fraud detection is the canonical machine learning example, pretty much. People have been talking about this since 2015, maybe even before. So this is 100% not an LLM problem. It's just bog standard, boring, normal machine learning. L'Oreal developed a AI agent to provide text-to-text and text-to-image generation capabilities. Did they really develop an agent to do that? Text-to-text, like, what does that mean? That probably means it's just an LLM call with a pre-described prompt. Text-to-image, like you just use an image generation model. That's tenuous at best. That sounds like one of those projects where you're kind of doing it for the sake of it rather than with a real use case in mind. But at least they are playing with AI agents. So that probably is, out of this whole list, the only agentic one. And so on. The rest of the 601 examples are all like this. They're really a huge mix of different implementations and techniques and technologies involved. Very few of them are agentic. Many of them are traditional machine learning. So even though we're talking about LLMs a lot today, always consider that LLMs are suited to a particular set of use cases. And I agree that there are a lot of use cases where they're really useful, but there's still all this other space to be searched for more general and other AI applications. I thought it might be useful to provide some statistics on how AI use cases are being used, and if you recall back, I segmented them into sort of two different types of use cases that you can attack. One is the product focused version of the problem where you're focusing on your product and your customer, and the use case where you are focusing on your own internal operational efficiency. Kind of depends on what business you're offering, basically. But two main themes here. And let's try and map that to some data that I pulled out of a report from Deloitte. So by far and away, if you look across the different functions within the business, the different departments, then the biggest user of GenAI, and we can infer from GenAI, they mean LLMs as well. The biggest user is IT. And I think that makes sense. IT is the most familiar with these technologies. A lot of the use cases are tailored towards IT users because they are IT users themselves. That's why coding assistants are probably the most advanced and most used agentic systems in use today. So there, that makes sense. After that, the next biggest is operations and marketing. Operations is a bit vague and a bit generic, but I guess that makes sense because if you're targeting operational efficiency type use cases in your business, then operational efficiency hits operations. Marketing is a really common use case. It's probably the biggest single. Not sure actually. Apart from, let me undo that. I'm going to take that back a little bit. But marketing is still obviously a really big use case because of the generative capability of these models. We can use them for writing text. We can use them for generating images and everything in between and after and before that. Really, really useful for marketing. And then we've got a variety of different parts here. Service, you can kind of consider that part of the operational efficiency again. Cyber, not entirely sure what that means, so we'll skip that one. And then product, it's a pretty broad category, but that probably targets all of the things that fall within customer and product efficiency. So I guess what we can maybe take away from this is that in general, most companies are targeting operational internal efficiencies with GenAI and LLMs more than they are targeting their product, which I find quite interesting because typically most companies kind of want to start with their product, but maybe they don't see how they fit it in. And then if we look at the bottom row now, we can look across these functions, these departments again, but for different particular industries. And I think probably the highlight here is the results are largely the same. IT is still at the top or near the top of all of these categories. I think, is there anything that stands out? Maybe it's maybe obvious. In financial services, for example, we've got finance being targeted for GenAI in financial services. That makes sense. In energy, resources, industrial, they're using it for more strategic kind of operations, like planning and things like that. Again, that makes sense. In the consumer sector, we are targeting customer service. So kind of, hopefully in your mind, it should make sense where you can start applying GenAI to in your business because it basically maps directly to what your business does. All right, so next let's consider how a project is run. No matter what scale or size of project that we work on, it typically follows a very common pattern. Thankfully, we're now working in a post-waterfall era, and most businesses are happy to appreciate that you can't build the perfect thing the first time, and so you iterate towards a viable and useful solution. And that involves a range of different steps going from ideation all the way through to production. But the goal is to try and get there as quickly as possible because you can't validate that your solution is going to prove its return on investment until you can actually get it in front of users. Now, you've got to be a bit careful because that is not a blanket statement. It very much depends on what type of automation of what thing you're targeting and what business you operate in. I was speaking to a business last week in a client meeting who said that their customers are incredibly picky. Let's say they when you deploy new changes or new features to their customers, you basically get one chance to get it right, and so they actually like the other end of the spectrum. They spend a lot of time prototyping, building MVPs, testing internally, but they never release any of this to the customer. They always wait until it's really, truly ready. And and then their customers love it. So it works for them. But the only reason why it works for them is because they have a really, really strong product function. They've got a really strong, powerful, large product team that basically makes sure that the problem definition is perfect, and they become like internal users for their users. So they have a pretty good idea for what their user wants. If you don't have that function, then obviously trying to build that up front is incredibly risky, because you might spend all that time and money developing it only to find that the users don't really like it, enjoy it, use it, whatever. So typically I would recommend trying to put things into production as soon as possible, and apologizing for the rough edges, call it beta, alpha, whatever, put some marketing around it, and then let them use it and decide and feedback. But yeah, case by case basis. So that iterative approach, though, still doesn't really fit that well with a traditional machine learning life cycle. And the main reason for that is that there's multiple points at where the ML life cycle can go wrong. This is an intentionally, complicated picture of the full ML life cycle. So don't worry about reading all of these things. But the point here is that it can be complicated, and the main reason for that is that there is unknown uncertainty within the data itself. In a traditional machine learning sense, there was always quite a high risk that the project would fail, purely because you didn't have the right data, purely because you couldn't find enough signal within that data to do something useful with it. However, that all changed a little bit when LLMs came out, because what it meant was that you can do a lot of prototyping on the data science side of the problem, on the data oriented part of the problem with just GenAI models. You can, for example, for a classic like classification type task, you could ask the GenAI model to do the classification for you, and it's not going to be good. It's not going to be as optimized as a proper machine learning model, but it might get you far enough to deliver an MVP, possibly something deployable, something to actually test out. And the reason why it can do that is because the underlying knowledge that has been trained into these models is so vast and so powerful that it can typically make a pretty good guess about the correct answer. Again, I'm not advocating that all models should be GenAI models, and actually the primary reason for that is that they're incredibly resource hungry. They're incredibly inefficient. It's like taking a V12 sports car to a lawnmower competition or something. You're wasting so much energy, so much power, so much expense on something that could probably be done with a much simpler machine learning model. But in terms of time to production, it can be really powerful for prototyping. Another thing that you'll need to consider along the way is to build or buy. This comes up very often, actually. Generally, you will want to buy something if it is not your core business to be in that game. So basically, if you've got generic use cases that apply to the rest of the world, then it's usually better to buy off the shelf. The classic example here is probably coding assistants. Like, unless you are involved in building a product that is a coding assistant, then you could probably buy something off the shelf that does that for you, rather than actually building your own. A couple of caveats to that, obviously, that we'll come to in just a second. But if it's not a core part of your business, then you've got to ask yourself why you want to be building it. Another reason to buy, and this is actually really important, is speed to market. If you can buy something off the shelf and white label it or take advantage of it in order to get you there quicker, then it could be just a stopgap. You can always buy it, use it, and then migrate away from it if it succeeds. When to build? I think really there's two sort of key reasons why you'd want to build. One is like the opposite of what I just said. It's when it's a core part of your business, when it's a core differentiator compared to your competition. Or the other most important thing is when you've got unique or private or important data. You probably don't want to be sending that sensitive, important data off to a third party. And so you should definitely consider building at that point, purely from a security perspective, purely from like a competitive perspective as well. And then the sort of the final and third categories, whenever you've got a unique or a bespoke use case that is only applicable to your business. It's very basically if you can't find something to buy, then you have to build it. That's that case there. Just highlighted in the brackets here are some statistics that come from the MIT report that I mentioned earlier, and it states the success rates of projects when you build versus when you buy. I don't think there's anything too egregious here. I think the success rate for when you try and build something is quite low. There's probably confounding variables here. This might be because the underlying problem definition was not defined very well. So it's not really a problem with when to build question. It was more about the problem definition in the first place. So I don't know, pinch of salt for this fairly low number. But I can certainly agree that building is probably more risking than buying. I think another thing that surprises me is that the buying figure is actually so low. Like, why is it only a success 67% of the time when you're buying it off the shelf? I think maybe it's just aggrandized expectations. Like, we tried a new AI sales assistant agent thing the other day, and it was rubbish. It was just not very good. So I guess if you consider that as a failure, then maybe 2/3 is probably about right. I think one of the final points that I want to make is a point I just touched on there. Your data, your private business proprietary data, is the one thing that your competition does not have. Your competition can use these GenAI models to build out the same workflows as you can. Your competition can probably hire similar talent. They can probably hire, people like us to help them with their endeavors. They can even probably copy your product. They can even copy your features of your product. But what they can't do is they can't copy your data if it's kept secure, and probably your domain expertise in that problem as well. That's incredibly hard. I mean, it's not impossible because you can poach, you can hire people from the other business, but those two things are generally the most unique parts of a business. And so you should really value your data. There is a lot of value in your data, and it might not be immediate, it might not be present at the moment, but when you start going down this sort of AI journey of trying to find the use cases and stuff, you'll immediately start finding that you either do or you don't have the data. And when you do, it's usually a really valuable proposition because your competitors can't replicate that. So, another thing to bear in mind when you're talking about use cases is think of data as an asset, because it is an asset to your use cases and it is something that other people want. So it could even be a secondary business for you. It can be you can sell that to other people. I think the knock-on effect of that, pressed the wrong button. Let's keep going. I think the knock-on effect of that is that you need to keep it private. You need to ensure that your data is private from these third parties. Let's try and go back again. There we go. And to do that, you need to build bespoke capabilities. You need to keep the data in-house. You need to use on-premise or secure private models. You need to leverage systems. We've got a product called Helix, and Helix is non-premise LLM platform, so it allows you to keep your private data on-premise and take advantage of all of the large language model capabilities that they offer. So you should consider systems like that. And I think all of these points are really important. So data is an asset, keep it private, but designing for data. So when you're thinking about your use cases, don't just think about how you can solve the user's problem. Also think about how you can generate more data. How can you gamify the problem so that you are generating even more data for your future endeavors, or to maybe to make that product even better, to give it a fuller, richer picture of what people are wanting when they're using your product, for example. So try and design those use cases for data. And I think you can just, in general, you can expect companies to have more and more data over time. Yeah. Stop there. Okay. Another thing, one thing that we haven't touched upon yet is the environmental cost of all of this. And I even speak to like my friends, my colleagues, my other engineers, and it's still not really resonating much. You really have to believe in the environment a lot more than I think most engineers do, to really kind of comprehend the environmental cost of all of this. But I think there's a really simple sort of market force that is pushing against this, and it's cost. In general, cost correlates with the environmental cost. If you are spending more money, you are generally using more, generating more carbon. And in some cases, there's been reports of an automation actually helping save energy. And usually, again, it correlates with time. So there was an example in a newspaper, an online newspaper called Adweek, which was talking about how ad copy writers for a big, for a leading ad company was spending 1,300 times less carbon for their ad generation work by leveraging AI and LLMs. So there's definitely opportunities there. Bear in mind the evidence paradox. It's this idea of where if you make something easier and easier to use, then you can expect a greater use of that thing, not less use. So I think the energy use of these models is only going to go up. A very small number of large enterprises actually measure their environmental footprint. There's a couple of really nice libraries emerging on the market. Ecologits was one. There's a couple of others. I forget the names. But effectively, they attempt to predict the amount of energy being used when you submit a request to a model. One of the worst offenders was GPT-4. It used 4.5 megajoules of energy for I think it was 1,000 requests they were measuring. And that's the equivalent of boiling a kettle for 30 minutes. Newer models and smaller models are obviously much better, but that was really, really, really bad. So I'm glad that's been discontinued now. I think in general, to kind of counter all of this negativity is to, again, focus on the cost, optimize for cost. That'll get you most of the way there. Use smaller models if you can. More smaller, more focused, more dedicated models. Batch requests into bigger workloads if you can. We can take advantage of efficiencies better when you batch them together. And similarly, use specialized models as well. So if you are using a specialized model, then it is usually a smaller model because you don't need all of those wasted neurons to be able to tell you what type of dog breed that particular picture is. You end up with a smaller model. So traditional ML comes under this as well. And building the team. I made a little pun here. Hope you like it. Building the team. So there's a range of new skills that are required for this new AI future. From a leader perspective, you need to be able to understand the AI landscape. And how to define the use cases and how they map to specific engineering patterns. Like, is it a machine learning problem? Is it an AI problem? Things like that. Statistics is still vitally important, I think, especially when it comes to engineers, because when you're working with these things, they are very uncertain. They generate different results each time. So you need to prompt it and especially test it in a statistical way. You can't write one test and expect it to pass every single time, because it won't. It will fail some proportion of the time. So you need to handle that. If you're in a product part of the business, then it can be really useful to understand which part of that 80-20 split you're in. If you know that if this particular problem falls within the 80%, you can be more confident that you can solve that. If it's in the 20%, then it's difficult. The only way really to kind of get that experience is by doing, unfortunately. It's quite hard to describe all of the different factors involved for a particular business, which is harder than, which problems are harder than others. I think from a skills perspective, I think they're basically the same as before. I think engineers are very well suited to the new AI world. Still need to think in terms of systems, in terms of the product. But it's the domain expertise and the experimental mindset that bring out the best in these kinds of problems. So I don't know what you want to call that, like some sort of AI literacy. You kind of need to know that it's there. You don't necessarily need to know how it works so much. I mean, even though that obviously helps, but having some awareness of it is the minimum, I guess. And then finally, what do we do? Okay, so action items for you right now. So what I would like you to get started on immediately is to take a look at how AI is being used within your business. Kind of like set your feet, figure out where you are. And the first thing you need to do is start identifying the next top 3 use cases. So this is quite an arduous process. And the main problem is that there's so many different possible use cases. It can be quite hard to prioritize them all. So really kind of focus on predicting, guessing, or establishing current metrics and trying to identify and prioritize those top 3 use cases that are the most valuable. They're the easiest to do, so on and so forth, everything that I've talked about. And if you need any help with doing that, then we offer a discovery workshop where we go through this process and we figure out where all those key use cases are, and then we map them to a difficulty scale effectively, and that helps us prioritize which are the 3 use cases you should tackle next. And once you have those 3 use cases, then you should start building them out. Building the pilot is not only vital to prove that you can actually do it, but also it builds the team experience. And that's where our development partnership comes in. So we can help you develop those pilots and develop those products, and we can work like directly with your team to help transfer our experience over to you. And then in the future, there's obviously going to be some organizational change as some of these pilots start hitting the big time. It might impact you operationally. If it's an operational use case, it might impact your product if it's a product use case. And then later down the line, things like governance, regulation, legality, these all become really important. So you need to start planning for that. Once you have your first few pilots under your belt, I would suggest, unless you're in a highly regulated industry, and that's where our AI consulting services can help. So this is where we're coming in and we're providing point guidance basically on specific subjects to help you overcome those organizational challenges. I hope you have enjoyed that talk today. It was a fairly long one, and mainly because there's quite a lot to talk about. There's a lot you need to know. AI projects are large, complex engineering projects, and so there's obviously a lot involved. If you have any questions about any of it, though, I'd love to hear from you. You can reach me at phil@winderai, or you can visit the website, WinderAI. I've got VCard information there. You can find me on LinkedIn. You can check out my book, etc., etc. I think in general, if you need any help, then definitely reach out as soon as you can. And hopefully you've learned something. So I'll leave it there. My name's been Dr. Phil Winder, and thank you for watching. Thank you. Bye-bye.